Hi everybody, welcome back to class. In this video, what we're going over is the last little topic here of our introduction into matter. We're looking at volume. So we've already studied length, we've already studied mass, now we're starting volume. Remember, length is the measure of a distance, or how far it is from point A to point B. Mass is the measure of the amount of matter in an object. And now we're going on to volume, which volume is the measure of the amount of space an object or a substance takes up. Anything that is matter takes up space, some space. It might not be a lot of space, but it'll take up some space. Now, you don't have to have something be very massive, meaning very heavy to you, to have a lot of volume. You may have something like, and Mr. Krupa is not an artist, a balloon, compared to, let's say, your cell phone. The balloon takes up much more space than your cell phone, but the balloon has much less mass. It's not as heavy as your cell phone. So the volume, more volume does not always mean more mass, but they both do take up space. And that's what we're looking at with volume. And in this class, the two most common ways you're going to measure volume are milliliters and cubic centimeters. Remember, cubic centimeters is centimeters cubed. Milliliters, that L there, will be capital for liters, and the M stands for the milli part. And the pictures down here at the bottom are talking about the three different ways we're going to be measuring volume. We have the volume of solids that are cubical. You got liquids. And then you have solids that are oddly shaped. They're oddly shaped. So let's go on from here. So you're used to measuring volume with these units. These are your English or customary units of volume: cups, pints, quarts, gallons. And this is stuff you've learned probably all the way back to elementary school, where how many cups are in a pint? There are 2 cups in a pint, 2 pints in a quart, and then there are 4 quarts in a gallon. Then you have other things like half gallons, and then you can go smaller than a cup, and we then go down to ounces. And you can go farther down from ounces. You can do teaspoons, tablespoons, all these little tiny pieces, all these different ways to measure volume. But these are all English. It's good to know them for just the general world, but we're going to be focusing on these in class. We're looking at the metric. For liquids, you're looking at milliliters and liters. Milliliters is smaller. Liters is bigger. You're used to seeing liters whenever you go to buy soda. You either buy them in a liter bottle or you buy them in 2-liter bottles if you're normally. You also could find the other 16-ounce bottles, but when I was thinking liters, I always think a bottle of soda, 2-liter bottle. Milliliters, even though you don't normally see it that often, you use that whenever you do buy a can of soda. It says 12-ounce cans on there, but it'll also give you the milliliters. The other place you use a milliliter is measurements for medicine. Whenever you take like Pepto-Bismol or Benadryl, they say to measure in milliliters. Now, just to give you an idea, milliliters is pretty small. It is 20 drops of water. So think about dropping water out of like an eyedropper. 20 drops would be about a milliliter. It's not that much. Now, the reason I have right now milliliters and cubic centimeters bolded down below is these are the most common units you're going to use in my class. Milliliters and cubic centimeters are the most common units you're going to use. Liters and meters cubed can be used, but we're looking at milliliters, cubic centimeters. 1 milliliter is equal to 1 cubic centimeter. That means up here we're, 1,000 milliliters equals 1,000 cubic centimeters. It's called a 1-to-1 ratio. They always equal one another. And this is really good because you can now use this, because if you have a cube, as we're going to find out, and you find the volume of the cube, you know exactly how much water can go in there because of this. You know exactly how much water can go in there because they equal one another. So let's move on here. Volume of a cubically shaped or regularly shaped object. And you've done this in math class before. This should not be anything new to you. Cubical objects are going to be measured in cubic centimeters. Now they could be measured in meters cubed, but mainly it's going to be cubic centimeters. That's going to be your go-to. You calculate this with length times width times height. Length times width times height. Nothing's changed since math class. The equation for that is right here. Length times width times height is for the volume of cubically shaped objects. Now you're used to having somebody say this is the width, this is the length, this is the height. When you do multiplication, it does not matter the order. You can identify them, but when you actually go to multiply, it does not matter which order you multiply it in, because when you think about it, 5 times 2 equals 10. 2 times 5 equals 10. No matter which way you multiply, you get the same answer. So no matter which order you put these in when you go to plug them in your calculator, you'll get the same answer. So in this case, length times width times height, we're going to say 3 centimeters times 4 centimeters times 5 centimeters. 3 times 4 times 5 gives you 60. The centimeters cubed comes because you did centimeters times centimeters times centimeters. That's how you get centimeters cubed. If you did centimeters times centimeters, you get centimeters squared, like for area. Now liquids. So we've done cubical, like regularly shaped objects. Now we're going to look at volume of liquids. With liquids, you measure them in milliliters. In this class, we are mainly going to be using milliliters. We don't have anything that's really going to measure liters. You need to know that this is a liter, like that is the symbol abbreviation for liters, but milliliters is your go-to in this class. And we're going to be measuring them in a graduated cylinder. And these picture here are all graduated cylinders. In my class, you will mostly be using a 100 milliliter graduated cylinder and a 10 milliliter graduated cylinder. To use a graduated cylinder, it's pretty easy. First thing you got to do, pour the liquid in. Not too complicated there. Next, you have to get eye level with it. And what I mean, the reason you're going to have to get eye level with it is you're going to have to squat down. You're going to have to make sure your eye's looking directly at the liquid, because what you're going to have to do is read it from this thing here called the meniscus, or the bubble. You have to read it from down there, because if you don't, your measurement's going to be off. You can see how it forms this bubble here, and it climbs up the side of the graduated cylinder. That's from another property we're not going to go into right now. But that bubble's called the meniscus, and you got to read from the bottom of the bubble. Some graduated cylinders won't form that bubble, and that's okay. But you want to make sure that you read from the bottom of the bubble. So the bottom of the meniscus is what it's called. After you read it from there, all you're going to do is record it to the proper number of decimal places. In this class, all of my graduated cylinders will be measured with 1 decimal place. All of my graduated cylinders that you use will only measure 1 decimal place. So that's where you have to pay attention. Meter sticks had 2 decimal places. Triple beam balance had 2 decimal places. And now you have the graduated cylinders, which only have 1 decimal place. You also got to make sure with the unit you use milliliters. When you're using the graduated cylinders, it's going to be in the unit milliliters. So when we look at the example over here to the side, it is 24.0 milliliters. That's at the bottom of the bubble here. If you would read from the top of the bubble, it's at 25 milliliters. We don't want to read from the top of the bubble. We want to read from the bottom of the bubble. So we're going with 24.0 milliliters. because it's 24.0, because right now when we look at it, it is dead on that line. It is dead on that line. If it fell in between, now we would have to guess a little, just like we would in for the meter sticks or the or the triple beam balances. The final way to measure volume is by a process called water displacement. And you have probably done this many times in your life and not even realized you did it. And you do this whenever you get into a bathtub. When you get into a bathtub, the water rises. It rises because you are taking up space in the bathtub. So however much you get in the bathtub, that's how much it pushes the water up by. That you are displacing the water. And you use water displacement when you can't use length times width times height. So for example, maybe a penny. You want to find the volume of a penny. You want to find the volume of a rock. You can't really use length times width times height, so you've got to go with water displacement. With water displacement, what you have to do is pour some liquid into a graduated cylinder. Usually it's water, so pour some water into a graduated cylinder and read that volume. When there's nothing in there but water, that's your initial volume. That is your initial volume. So let's go green for beginning. Green means go. Green is initial. So initial volume, that's where you started. That has nothing in there other than the liquid. Then you will add the objects to the graduated cylinder. After you add the objects to the graduated cylinder, you will see the water level rise. You will record this new volume. This new volume, let's go with red, will be your final volume. That's the VF. That F means final, I means initial. And then you use those to calculate the volume of the object, or VO. That O stands for object. So that O here stands for object. The F is for final, and the I is for initial. An example of that is shown here. Right here, we have a graduated cylinder with nothing in it but water on the left. That water is at 4.00 milliliters. That's going to be your VI, initial volume. Then we added two, looks like rubber balls here. So we have those. When you add them, the water goes up. It goes up to 6.00 milliliters over here. Or 6.0, not 00, 6.0 milliliters. That's going to be your final volume. That's your volume after adding the objects. You then do this equation right here. To find the volume of the object, VO, you take VF minus VI. So VF was 6 milliliters minus 4 milliliters. And you get an answer of 2.0 milliliters when you do the math. That means the two red spheres there have a combined volume of 2.0 milliliters. That's how you use water displacement. If you have any questions with this topic, please feel free to reach out to me. Please feel free to email me and contact me. I hope you have a wonderful day, everybody.